Hello everyone, I'm Matashimi and I'm here with another tutorial about machine learning and deep learning. I hope you liked the other courses and made the most out of them. First, I want to talk to you about machine learning and deep learning, and then let's use it together in practical projects. Machine learning is a type of artificial intelligence that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict no output values. Recommendation engines are a common use case for machine learning. Other popular uses include fraud detection, spam filtering, malware threat detection, business process automation, and predictive maintenance. Machine learning is important because it gives enterprises a view of trends in customer behavior and business operational patterns, as well as supported the development of new products. Many of today's leading companies, such as Facebook, Google, and Uber, make machine learning a central part of their operations. Machine learning has become a significant competitive differentiator for many companies. Classical machine learning is often categorized by how an algorithm learns to become more accurate in its predictions. There are four basic approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. The type of algorithm data scientists choose to use depends on what type of data they want to predict. This type of machine learning data scientists apply algorithms with labeled training data and define the variables they want the algorithm to assess for correlations. Both the input and output of the algorithm is specified. This type of machine learning involves algorithms that train on unlabeled data. The algorithm scans through the dataset looking for any meaningful connection. The data that algorithm train on, as well as the predictions or recommendations they output, are predetermined. This approach to machine learning involves a mix of the two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the dataset. Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works out how to complete the task. But for the most part, the algorithm decides on its own what steps to take along the way. Supervised machine learning requires the data scientist to train the algorithm with both labeled inputs and desired outputs. Supervised learning algorithms are good for the following tasks: binary classification, divided data in two categories, multi-class classification, choosing between more than two types of answers, regression modeling, predicting continuous values, and assembling, combining the predictions of multiple machine learning models to produce an accurate prediction. Unsupervised machine learning algorithms do not require data to be labeled. They sift through unlabeled data to look for patterns that can be used to group data points into subsets. Most types of deep learning, including neural networks, are unsupervised algorithms. Unsupervised learning algorithms are good for the following tasks: clustering, splitting the dataset into groups based on similarity; anomaly detection, identifying unusual data points in a dataset; association mining, identifying sets of items in a dataset that frequently occur together; and dimensionality reduction, reducing the number of variables in a dataset. Semi-supervised learning works by data scientists, feeding small amount of labeled training data to an algorithm. From this, the algorithm learns the dimensions of the dataset, which it can then apply to new unlabeled data. The performance of algorithms typically improves when they train on labeled datasets. But labeling data can be time-consuming and expensive. Semi-supervised learning strikes a middle ground between the performance of supervised learning and the efficiency of unsupervised learning. Some areas where semi-supervised learning is used include machine translation, teaching algorithms to translate language based on less than a full dictionary of words; fraud detection, identifying cases of fraud when you only have a few positive examples; labeling data, algorithms trained on small datasets can learn to apply data labels to large sets automatically. Reinforcement learning works by programming an algorithm with a distinct goal and a prescribed set of rules for accomplishing the goal. Data scientists also program the algorithm to seek positive rewards, which it receives when it performs an action that is beneficial toward the ultimate goal, and avoid punishments, which it receives when it performs an action that gets it further away from its ultimate goal. Reinforcement learning is often used in areas such as robotics. Robots can learn to perform tasks the physical world using this technique. Video gameplay. Reinforcement learning has been used to teach bots to play a number of video games. And reinforcement management. Given finite resources and a defined goal, reinforcement learning can help enterprises plan out how to allocate resources. Today, machine learning is used in a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommendation engine that powers Facebook's news feed. Facebook uses machine learning to personalize how each member's feed is delivered. If a member frequently stops to read a particular group's posts, the recommendation engine will start to show more of that group's activity earlier in a feed. Behind the scenes, the engine is attempting to reinforce known patterns in a member's online behavior. Should the member change patterns and fail to read posts from that group in the coming weeks, the newsfeed will adjust accordingly. In addition to recommendation engines, other uses for machine learning include the following: customer relationship management. CRM software can be machine learning models to analyze email and prompt sales team members to respond to the most important message first. More advanced systems can even recommend potentially effective responses. Business intelligence. BI and analytics vendors use machine learning in their software to identify potentially important data points, patterns of data points, and anomalies. Human resource information systems, HRIS systems, can use machine learning models to filter through applications and identify the best candidates for an open position. self-driving cars. Machine learning algorithms can even make it possible for a semi-autonomous car to recognize a partially visible object and alert the drive. And virtual assistants. Smart assistants typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. Machine learning has seen use cases ranging from predicting customer behavior to forming the operating system for self-driving cars. When it comes to advantages, machine learning can help enterprises understand their customers at a deeper level. By collecting customer data and correlating it with behaviors over time, machine learning algorithms can learn associations and help teams tailor product development and marketing initiatives to customer demand. Some companies use machine learning as a primary driver in their business models. Uber, for example, uses algorithms to match drivers with riders. Google uses machine learning to surface the right advertisements in search. But machine learning comes with disadvantages. First and foremost, it can be expensive. Machine learning projects are typically driven by data scientists who command high salaries. These projects also require software infrastructure that can be expensive. There is also the problem of machine learning bias. Algorithms trained on datasets that exclude certain populations or contain errors can lead to inaccurate models of the world that at best fail and at worst are discriminatory. When an enterprise bases core business processes on biased models, it can run into regulatory and reputational harm. The process of choosing the right machine learning model to solve a problem can be time-consuming if not approached strategically. Step 1. Align the problem with potential data inputs that should be considered for the solution. This step requires help from data scientists and experts who have a deep understanding of the problem. Step 2. Collect data, format it, and label the data if necessary. This step is typically led by data scientists with help from data wrangles. Step 3. Choose which algorithm to use and set to see how well they perform. This step is usually carried out by data scientists. And step 4. Continue to fine-tune outputs until they reach an acceptable level of accuracy. This step is usually carried out by data scientists with feedback from experts who have a deep understanding of the problem. Explaining how a specific machine learning model works can be challenging when the model is complex. There are some vertical industries where data scientists have to use simple machine learning models because it's important for the business to explain how every decision was made. This is especially true in industries with heavy compliance burdens such as banking and insurance. Complex models can produce accurate predictions, but explaining to a layperson how an output was determined can be difficult. While machine learning algorithms have been around for decades, they've attained new popularity as artificial intelligence has grown in prominence. Deep learning models, in particular, power today's most advanced AI applications. Machine learning platforms are among enterprise technology's most competitive realms, with most major vendors, including Amazon, Google, Microsoft, IBM, and others, racing to sign customers up for platform services that cover the spectrum of machine learning activities, including data collection, data preparation, data classification, model building, and application development. As machine learning continues to increase in importance to business operations, and artificial intelligence becomes more particular in enterprises settings, the machine learning platform wars will only intensify. Continued research into deep learning and artificial intelligence is increasingly focused on developing more general applications. Today's AI models requires intensive training in order to produce an algorithm that is highly optimized to perform one task. But some researchers are exploring ways to make models more flexible and are seeking technologies that allow a machine to apply context learned from one task to future different tasks.